attend this visiting lecture today. So on behalf of the organizing committee, I extend a very welcome to each of you. We are honored to be in your presence, and I look forward to the rich exchange of ideas and perspectives in this session promises. It is with great honor and anticipation that we introduce today's lecturers, Mr. D. Asir and Mr. S. Maria Shobana from Kamaraj College of Engineering and Technology, India. So welcome to the lecture. Now, as we advance to the first session of the lecture, let us extend a warm virtual welcome for our esteemed lecturer for today's visiting lecture, Mr. Asir. Okay, now, before we begin the lecture, I encourage all attendees to engage actively throughout the session. Please feel free to use the chat box or the Q&A feature to share your thoughts and questions. And just a quick note to our speakers that each session is scheduled for approximately 1 hour, including both the presentation and the Q&A session. Therefore, we kindly ask our speaker to be mindful of the presentation duration so that we can also have a meaningful and engaging discussion during the Q&A. Thank you. All right, Mr. Asir, you may begin.
Thank you, ma'am. So, good afternoon, everyone. First of all, I would like to thank the organizers for giving me this wonderful opportunity to interact with all of you. I am Asir, and I am working as an assistant professor at Kamaraj College of Engineering and Technology, Tamil Nadu, India. It's truly an honor for me to deliver this international visiting lecture, which is organized by the University of Science and Computer Technology in collaboration with STEKOM. I sincerely thank the organizing team for inviting me to share my knowledge and interact with the students and faculty members through this academic collaboration. Now, coming to today's session, I am very happy to be here today to speak about one of the most powerful and fastest growing technologies in the world, machine learning. Before we begin, let me ask a few simple questions. How many of you use YouTube regularly? How does YouTube know exactly what videos you want to watch next? How does Amazon recommend products that match your interest? And how does the Google Map predict the traffic before you even leave your home? All of these intelligent systems are powered by machine learning. In today's session, we are going to explore the fundamentals of machine learning, understand its types, also discuss some important algorithms and how it is applied in real-world systems. In today's sessions, we will cover several important topics related to the machine learning. First, we will understand what machine learning actually means. Next, we will discuss different types of machine learning, such as supervised learning, unsupervised learning, and reinforcement learning. Then we look at some popular algorithms used to build machine learning models. After that, we will explore some important concepts like overfitting, underfitting, bias, and variance, which are essential for building the effective machine learning models. We will also discuss real-time, real-world applications where machine learning is currently being used. So first of all, what is machine learning? You know that machine learning is a branch of artificial intelligence that allows the computers to learn patterns from data and make decisions without being explicitly programmed. In traditional programming, developers write detailed rules and instructions. For example, in traditional programming, input plus programming rules, it reflects or it produces output. However, writing rules for every situation is very difficult. Instead of this, we are using the machine learning. Machine learning follows a different approach in machine learning. So we import input data plus expected output as a pair, as a label. Machine learns the rules automatically. The system analyzes the patterns in data and builds a model, mathematical model. Once the model is trained, it can make predictions on new data. So examples of machine learning. Suppose we want to predict students' mark based on the number of hours they study. We collect some data from previous data set. For example, 1 hour of study, 35 marks, 2 hours of study, 45 marks. If the student studied for 3 hours, he got 55 marks. From this data, the machine learning algorithms identifies a pattern. After learning this pattern, the system can predict the marks for a student who studies for 6 hours. So this process of learning patterns from past data and making predictions for the future data is the basic idea. So from this, we conclude that machine learning predict the result for the new data from the past data. Why we go for the machine learning? First one, the amount of data generated every day is huge. Second, the social media platforms, online transactions, and sensors and mobile devices generated a huge amount of data. To analyze this data manually, it is impossible. So we go for the machine learning systems. Also, the organizers want to make smarter and the faster growth. Machine learning systems can analyze the patterns and provide accurate predictions. Machine learning helps automate the complex tasks that were previously done by the humans. Finally, the accuracy of the machine learning models improves as more data becomes available. So these are all the major categories comes under this machine learning. So machine learning classified into 3 types: supervised learning. So the first type is supervised learning. The second type is unsupervised learning, and the third one is reinforcement learning. Each type of learning works differently and is suitable for different types of problems. I give the example for the supervised learning. Supervised learning is one of the most commonly used machine learning techniques. In supervised learning, the data set contains both input data and the correct output. This means the model learns using label examples. If you want to detect spam emails, we provide many examples of emails labeled as spam or not. Similarly, if you want to predict student performance, we provide data such as study hours and the corresponding marks. The algorithms learns the relationship between the inputs and outputs. Once the training is completed, the model can predict the output for the new data. So this is a supervised learning. In supervised learning, we are having 2 categories. First one is classifications, another one is recursion. The first category is classification. In classification, the output is category or label. For example, we are going to predict whether an email is spam or not. It is a category. Once it is a legitimate mail or otherwise it is a spam mail. Same thing, whether we are predicting whether a student will pass or fail. So in recursion, so we are going to predict the numerical values. Numerical values means we are not comes under the category. We are going to get some numerical value as the output. Examples include predicting house price, predicting temperature, or forecasting sales. So in simple terms, classifications predicts category, while recursion predicts numbers. So the next main type is unsupervised learning. In unsupervised learning, the data does not contain labeled outputs. The algorithm receives only the input data. Its task is to identify the hidden patterns and relationship within the data. One common applications of unsupervised learning is clustering. Clustering is grouping. So clustering means, for example, the companies may analyze the customers' purchasing behavior by to group customers into different segments based on their age, based on their frequently visiting to the shop. Like that, we are going to segment or categorize the customers. The third type is reinforcement learning. Reinforcement learning, the learning through the reward and punishments. Here, the agent plays a major role in reinforcement learning. There is an agent that he interacts with the environment. So the agent performs action. If the action leads to good result, then the agent receives a award. If the agent leads to bad result, the agent receives a penalty. Over time, the agent learns which actions produce the best result. Reinforcement learning is widely used in robotics, gaming, game playing, and autonomous systems. So the popular ML algorithms used to model the ML system. So the linear recursion, logistic recursion, decision tree, and k nearest neighbors support vector machine. So these are all some of the important algorithms used in the ML model development. So the first one, linear recursion. Linear recursion, it mainly used to recursion problems where we want to predict the continuous value. So the algorithm finds the best straight line that fits the data points. The formula is y equal to mx plus c. Here the m is a slope and c is a intercept. Y is the predicted outcome and x is the input variable. So the formula for the straight line calculations, y is equal to mx plus c, y is a predicted variable, x is the input variable, m is the slope, and c is the intercept. Linear recursions is widely used in predicting sales, stock price, and other numerical values. In linear recursion, we are having two types of variables. One is input variable, another one is dependent variables. Input variable is a independent variable and the output variable is a dependent variable. For example, we use the example of hours studied and exam score. When students study more hours, their exam scores generally increase. So the exam score is a dependent variable. So hours studied is an input, it is an independent variable. This shows a relationship between the study time and the performance. In this example, the independent variable is hours studied. This is a factor we observe or control. And the dependent variable is exam score. This value depends on the number of hours studied. Next, from this, we are going to use the best fit line. Best fit line, it is used to, here we are going to draw the straight line that represents the relationship between the independent variable and the dependent variable. The best line shows the trend of the data and helps in making the predictions. It also minimizes the difference between the actual data and the predicted data. This difference between the actual and the predicted data values is called as the residual error. Here is a graph. So in this graph, the y is called as a dependent or target variable. X is called as a independent variable. Y is the output variable or dependent variable. X is a independent variable or input variable. Here we use the terms theta 1, theta 2. So the theta 1 represents the intercept and the theta 2 represents the slope. So we have to know about what is meant by slope and what is meant by intercept. Y is equal to theta 1 plus theta 2 of theta 2x. It is similar to the straight line equation y equal to mx plus c. The c is here given as theta 1 and m is given as theta 2. So we already told that slope defines the theta 2 or m. The slope of the best fit line indicate how much the dependent variable changes with each unit change in the independent variable. What are how the dependent variable change in proportional to the changes in the independent variable. For example, if the slope is 5, it means that for every 1 unit increase in x, the value of y increase 5. Next, the intercept. When the x value is 0, then what is the value of y? That relation is given in intercept. So the equations of the best fit line. So y is equal to mx plus b. So here the y is the predicted value or dependent variable. X is the input independent variable and m is the slope of the line, how much y changes when x changes. B is the intercept value, the value of y when x is equal to 0. Next, how we are going to minimizing the error, the least squares method. To find the best fit line, we use a method called least square. The idea behind this method is to minimize the sum of square difference between the actual value and the predicted value from the line. So the difference are called as residuals. The formula is residual is equal to yi minus yi cap. Here the yi is predicted value and the yi cap is actual value. So there are two types of linear recursion. So the first one is simple linear recursion, and the another one is multiple linear recursion. So the simple linear recursion, the formula is y cap is equal to theta 0 plus theta 1 x. Here the y cap is predicted variable value, and theta 0 is intercept and theta 1 is slope and x is the input variable. So for example, we are using that simple linear recursions in predicting a person's salary based on their years of experience. Next, multiple linear recursion. So multiple linear recursion involves more than one independent variable and one dependent variable. In simple linear recursion, we calculate the dependent variable with only one independent variable, but in the multiple linear recursions, we are using multiple independent variable to predict one dependent variable. So that is the difference. In simple linear regression, we are using only one independent variable. In multiple linear regression, we use n number of independent variable. In multiple linear regression, so y cap equal to the equation is theta 0 plus theta 1 x1 plus theta 2 x2 up to theta n xn. Here the y cap is the predicted value, x1, x2, x3 up to xn is the input variables, input independent variables. And theta 1, theta 2, theta n, these are all the coefficient, or we say these are all the slope. And theta 0 is the intercept. Right. So now we are going to evaluate the linear regression algorithm by using the following metrics. So these are all the evaluation metrics. The first one, mean square error. So mean square error is an evaluation metric that calculates the average of the squared difference between the actual value and predicted values for all the data points. If the data set has 20 data points, then we have to find the difference between the actual and the predicted values. The difference is squared to ensure that negative and positive difference don't cancel each other. So the formula is MSE equal to 1 divided by n. Summation of I equal to 1 to n. If there are 20 data in the data set, then the I value is 1 to 20. Yi minus yi cap whole square. Yi defines the observed value or actual value. Y cap is a predicted value. Next, mean absolute error, MAE. MAE, to find the formula, is 1 divided by n. So summation of I is equal to 1 to n, absolute difference of yi minus yi cap. Here also the n is the total number of data, so that we are going to use to train the model by using this regression algorithm. So yi is a observed value or input value, yi is a predicted value, yi is actual value, yi cap is a predicted value. So the mean absolute error is an evaluation trick used to calculate the accuracy of the regression model. MAE measures the average absolute difference between the predicted values and the actual value. Next, the root mean square error. So MSE. It describes how well the observed value data points match the expected values or the model's absolute fit to the data. So in mathematical notations, RMSE, so equal to square root of RSS divided by n. So we simplify this, that summation of I is equal to 2 to n. So yi is actual data minus predicted data whole square divided by n. Here n is the number of observations and y is actual values and y cap is a predicted values. Next, also we are having the R squared value. R squared we calculate by 1 minus RSS by TSS. That RSS goes for yi minus b naught minus xi whole squared, and the TSS stands for y minus y naught. Y minus y naught means actual value minus predicted value whole square. By using these measurements, we evaluate the algorithm's effectiveness in practice. Next, the decision tree is the next algorithm. So in decision tree, a decision tree is a model. This is a model that looks like a tree structure or a flow chart. Each internal node represents a questions about the data. For example, each branch represents a possible answer. Each leaf node represents the final prediction. For example, if a decision tree for predicting the student performance might ask questions such as, is attendance greater than 75%? If yes, the student may pass. If no, the model may check the study hours. decision tree are easy to understand and interpret. So decision tree means we are going to check the condition. If the condition is true, then we go for one output. If the condition is false, then we check the another decision condition. First thing, if the student has attendance greater than 75%, if yes, he may pass. Otherwise, we check another one decision condition, whether the model will check the study hours. If he study for more than 7 hours per day, then he will pass. Next algorithm, K nearest neighbors algorithm. So it is commonly known as KNN. The idea behind KNN is based on similarity. When a new data point appears, the algorithms looks at the nearest existing data points in the data set. The value of K represents the number of neighbors considered. Actually, the K nearest neighbors is often used for classification task. The next important algorithm is support vector machine. Actually, that support vector machine works particularly well for high dimensional data sets. The goal is to find the best boundary that separates data points belonging to different classes. This boundary is also called as hyperplane. Next, the important concepts, overfitting, underfitting. So while building a machine learning models, we must understand some important concepts. Two of the most common problems are overfitting, underfitting. Overfitting occurs when a model learns the training data too well, including noise and irrelevant data. As a result, the model performs poorly on new data. Underfitting occurs when the model is too simple and fails to capture the underlying pattern in the data. To build a good model, we must find the right balance between these two extremes. So next, the classification metrics. Classify the algorithms, we have to follow these metrics. To measure the performance of machine learning models, we use this evaluation metrics: accuracy, precision, recall, and F1 score. Accuracy measures the percentage of correct prediction. Precision measures how many predicted positives are actually correct. Recall measures how many actual positives were correctly identified. So now I will demonstrate a simple applications of supervised learning. Listen, so in this example, we are predicting a student's exam mark based on the number of hours they studied, right? Here the input variable is study hours and the output variable is marks obtained. So the input variable study hour is independent variable and the output variable mark is dependent variable. The model learns the relationship between these two variables using data. In this demo, I have implemented three supervised learning algorithms: linear regression, ridge, and KNN. First, I will load the sample data set. I load the sample data set, which contains around 30 study hours and marks pair. Right. Next, I will select algorithm linear regression and train the model. You can see that the system automatically fits a regression line on the scatter plot showing the relationship between the student hours and marks. For example, in the data set, the first data is for 1 hour, the mark will be 35. If the student studied for 1 hour, he got 35 marks. So in the scatter plot, so on the x-axis 0, 2, that's are all hours. And the y-axis, the marks are 0, 20, 40, 60, 80, 100. So for 1 hour, the student got 35 marks. So there is a point plotted on that. So for that y is equal to mx plus the straight line, the data are fit on that line. You can see that the system automatically fit a regression line on the scatter plot showing the relationship. So finally, we can enter any new study hour data and the model will predict the expected mark. For example, so now I am going to give 6 hours. So the answer will be 74. So the grade is C. We train the model with 30 data set, and we use the algorithm linear regression. So it automatically predict the student mark for the in 6 hour study. Right. Here there is some calculations. We calculate the MAE, R, MSE, and R squared value. So we know that for calculating the mean square error or mean absolute error, we have the formula. For calculating the mean absolute error, so the formula is 1 divided by n, absolute difference between the actual and the predicted value. Here, the 6 hour study, the predicted value is 74, and in the actual data, you see this for 6 hours here, the date in the data set 6 hours, the mark will be, if the student studied for 6 hours, he or she got a mark of 78. So 78, but the predicted actual value is 78, the predicted value is 74. From using this difference, we are going to calculate the MAE. So I am explaining about the one data. So in the data set, we are having 30 more data. So for the 30 more data, we calculate the MAE for the using the formula 1 by n yi minus yi dash. Yi for the first data, y1 minus y1 cap. So the what is the absolute difference plus the second data absolute difference, third data absolute difference. The absolute difference means the difference between the actual data given the data set and what is the data predicted by the model. So next, RMSE. So for that also we know the formula square root of RSS divided by n. That means RSS means summation of I is equal to n yi minus yi cap whole square divided by n. So here also we are going to calculate the difference between the actual data and the predicted data whole square for 30 data. In the data set, we are having 30 data. For all 30 data, so we are going to find the difference between the actual and predicted value. Then we have to perform the square root for that. We will get the answer of 0.913. The next example is spam sentinel. That means we are going to find whether the given mail is spam mail or not. We are going to find it by using the ML algorithm. So first we are going to load some sample mails. So we load the sample mails. And we already fixed that in that 40 mails, 20 of them are spam mail and another 20 are legitimate mail, right? So now, so we are using some decision tree algorithms and we are going to train the classifier. Now I type, so the input, now I am typing one example, 2 crores, 2 crores in some lottery, right? I received a mail like this. Now I check whether this mail is spam or not. So classify mail, and it says that it is a spam detected. How we detect that it is a spam mail? Based on the spam keywords, we already model the system by using some factors, spam keywords and exclamation marks, some URLs, the money patterns. I sent that 2 crores, that is some money. Right. From this algorithm, we calculate the accuracy, precision, recall, F1 score. We know that the formula for finding the accuracy is find the accuracy equal to number of corrected prediction divided by total prediction into 100. Using that formula, we can find the accuracy. Right here, there is a confusion matrix. So what is meant by confusion matrix? It is also one of the metric. So confusion matrix means it is a grid. It is a 2x2 matrix. It is a 2x2 matrix. 0 0 0 1 1 0 1 1. 0 0 it represents true positive. 0 1 it represents false positive, and 1 0 it represents false negative. 1 1 it represents true negative. What is meant by true positive? True positive means it correctly predicted the spam mail. True positive means it correctly predicted the spam mail. So totally in the data set, totally there are 20 spam mail it correctly predicted, right? So next, FP means incorrectly predicted the positive, incorrectly predicted the spam mail. That terms defines 0. That means there will be no incorrect prediction for the spam mail. Next, 1 0 means false negative, incorrectly predicted the legitimate mail. Incorrectly predicted legitimate mail. The last one, 1 1 means true negative. True negative means correctly predicted the legitimate mail. So there are totally 40 data, the 40 mails. In that 40 mails, 20 mails are spam mails and another 20 are legitimate mail. From that measurements metrics, we conclude that in the confusion matrix, so the true positive, the correctly predicted spam mails are 20, and correctly predicted legitimate mails are 20. Using this confusion matrix, we find the precision recall F1 score. For finding the precision, we are having the formula TP by TP plus FP. TP means true positive divided by true positive plus false positive. That means correctly predicted spam mail divided by correctly predicted spam mail plus incorrectly predicted spam mail. That means 20 divided by 20 plus 0. So the answer is 100%. Right? Like that, recall. So to find the recall, we are having the formula true positive divided by true positive plus false negative. That means correctly predicted spam mail divided by correctly predicted spam mail plus incorrectly predicted legitimate mail. So this column, the first column. The first column represents the recall. The first row represents the precision. Next, F1 score. F1 score, we are having the formula 2 into precision into recall divided by precision plus recall. We know that precision TP divided by TP plus FP. Recall TP divided by TP plus F1. So using that formulas, we calculate all this: accuracy, precision, recall, and F1 score. So the next one is decision predictor. So here we are going to train 80 patients data. So this is not a real data. So we are going to train the model using random forest, and we give some inputs. What are the inputs? The diabetics and heart disease and the breast cancer. For that, we give some input. What is whether is in pregnancy stage, and the blood pressure, what is the blood pressure, insulin level, and diabetics, and what is the glucose level, and the skin thickness, what is body mass index, and the age. Using this input data, we are going to predict whether he is having diabetic or not. So based on the past data that is in the data sets, the model predicts whether he is having the diabetic problem or not. Also for the heart disease, so age, chest pain, and the major results, all these are given as a input. And we train the model, train the model and predict whether he has that heart disease or not. He display that low risk. That means based on the previous experience data, it comes to predict that having the low risk of heart disease. And also we are finding the accuracy, precision, and recall F1 score based on the confusion matrix. So these are all some of the supervised learning applications. Next, we discuss, already we told that what is meant by unsupervised learning. In the unsupervised learning, we are not going to train the model with the label data. Label data means we don't give input and output, only we give the input. Based on the input, they are going to make a cluster. See this. Now I demonstrate an example of unsupervised learning, which is customer segmentation. In many companies, customer purchasing behavior is analyzed to group customers into different segments. Unlike supervised learning, here we do not have predefined labels. The algorithm automatically discovers the patterns and group similar customers together. In this demo, the segmentation is based on the several customer features such as annual spending, purchase frequency, average value, average order value, loyalty score, recency of purchase, and the customer age. First, we load data sets containing around 200 customer records. Each record represents a customer with their purchasing behavior. First, I load that. Next, we choose one of the three clustering algorithms implemented from scratch. K means hierarchical clustering, anything. So it's I choose K means. Here there is a graph. The result are visualized using the scatter plots or radar charts, allowing us to clearly see the characteristics of each customer segments. If you want to change the input, so based on the average order and average order, I want to, based on the average order and the recency of visit, I want to visualize the scatter plot here. So these are all the groups, characteristics of each customer group segments is shown in this graph. This demonstration shows how unsupervised learning helps business understand customer behavior and create the targeted marketing strategy for different customer groups. So these are all the customer records. So if you want to change the value, we can change it. For example, So here is a formula for finding the accuracy, precision, recall, and F1 score. Next, so the last part. Uh, so the machine learning applications. So machine learning is widely used in many industries. In healthcare, so the machine learning helps predict disease and analyze medical images. In finance, it is used to detect the fraud and transactions. In e-commerce, machine learning powers recommended systems. Also, in social area platforms, machine learning is used for face recognitions and content filtering. So the first one, so in the healthcare, machine learning is reforming healthcare by improving diagnosis, treatment, drug discovery, and patient care. So ML model analyze patient health data such as medical history, blood test results, and genetic information. So using this data, ML algorithms can predict disease before they become severe. ML systems can predict the risk of heart disease, diabetes, cancers. So for instance, hospitals use ML models to predict diabetes and
I'm sorry, there seems to be a misconnection with Mr. Asir. Hello, Mr. Asir. Uh,
sorry for the interruption.
okay.
So the applications of machine learning in the finance. So the financial institutions use machine learning to detect the fraud, manage risk, and improve customer services. So machine learning models analyze the transaction data such as transaction amount, location, device used, and purchase patterns. If a transaction behave abnormal compared to previous patterns, the system flags it as suspicious. So a credit card normally used in India suddenly shows a transaction from another country. ML systems immediately detect the anomaly and block the
Excuse me,
transactions.
Mr. Amir. We only have 5 minutes left, and then we go to the Q&A session, just to inform.
Excuse me, ma'am.
Excuse me, can you hear me?
Yeah, I am hearing.
Okay, we only have 5 minutes left for the
Okay,
presentation.
okay,
So
okay. So the algorithms used for this financial management using machine learnings are the random forest and the neural networks. So machine learnings in e-commerce. So the machine learning plays a crucial role in improving customer experience and the business revenue. So the online platforms recommend products based on user browsing history, purchase history, and rating and reviews. So example, the e-commerce platforms, Amazon, Flipkart, Netflix. So the user buys or views a product, the system recommends similar or related items. So happen by using the ML algorithms. So the algorithms used are collaborative filtering, content-based filtering, and matrix factorization. So for the social media, the social media platforms rely heavily on machine learning to manage billions of users and content. So the major platforms include Facebook, Insta, and YouTube. So that ML is used for the face recognition and extract the face in image, extract the facial features and compare with the database. So the technology used for this social media applications for the deep learning and the convolutional neural networks. So the last one, so autonomous vehicles. So for the self-driving cars, rely heavily on machine learning to understand the environment and make driving decisions. Example, the Tesla. Here, the machine learning algorithms are used for object detections, and the self-learning cars use sensors such as cameras, radar, and lidar. Machine learning models analyze this data to detect vehicles, traffic signals, road signs, and obstacles. So the workflow example is the camera image and the ML model, and it identifies the objects. The navigations and the path planning of the vehicle must determine so which lane to drive in, when to stop, when to turn, how to avoid the obstacles. So all these decisions happen within the milliseconds. So benefits of using the machine learning algorithms in autonomous vehicles are to reduce the human errors and safer roads and improve transportation's efficiency. These are some of the introductions about the machine learnings. What are the type? What is machine learning? What are the types of machine learnings? So what are the important algorithms we use to model or train the systems? And the last applications of machine learnings. So this is all the introduction parts. So thank you for thanks from my thanks. That's all from my side. Do you have any questions?
all right, thank you, Mr. Asir, for such an enlightening and thought-provoking presentation. We will now begin our Q&A session where you can engage directly with our esteemed speaker and explore the topic in greater depth. So if you have any questions, please don't hesitate to type them in the chat box or use the raise hand feature. As we wait for other questions, it seems like we already have questions for you, Mr. Asir. Let me read it to you. Okay. First is from roughly France. Good afternoon, sir. As machine learning becomes more accessible to non-tech individuals, what key concepts should beginners focus on first in order to understand how machine learning works in real-world applications? Mr. Amr? Asir?
Ma'am, the question is posted in the chat.
The question is, it's from roughly France. He asked about as machine learning becomes more accessible to non-tech individuals, what key concepts should beginners focus on first in order to understand how machine learning works in real-world applications? Excuse me, sir.
Ma'am, audible? Hello?
Hello?
Ma'am, the
Are you
general
ready?
answer. So machine learning used in main real world application unlike the and admin- wait,
Take your time, Mr. Asir. Mr. Asir, hello? Okay. Seems like the connection is lost. All right. Seems like Mr. Asir has some connection problems. Well, there are still questions being unanswered. Please wait for a minute as we contact Mr. Asir. Hello, Miss Maria. Miss Maria, are you here with us?
Yes, ma'am. Am I audible now?
Uh,
Hello, ma'am.
yes. Good
I'm
afternoon, Mr.
audible.
Maria.
Yes,
Yes.
ma'am. Good afternoon. Shall I start the session now?
I think yes, because Mr. Asir seems like the connection was lost. So I think we may begin first for Miss Maria's presentation.
Okay, ma'am. Shall I share the presentation now?
Yes, please.
Okay, thank you.
Oh, and please turn on the camera so we can see
Okay.
while you present.
Yes. Wait. Now let's start the session.
All right. I'm really sorry. There seems to be a connection problem with their site. So please wait a minute as we.
I'm audible now, but your voice
Yes,
not.
miss.
Okay, ma'am. Sorry, ma'am. Network issue.
Okay.
Okay,
Yeah, it's okay.
okay,
You may continue the presentation. So.
okay. Okay, ma'am. The history of generative AI. The generative AI.
Oh, and
Yes, ma'am.
Miss Maria,
Yes,
please
ma'am.
turn on your camera so you can
Okay,
see while you present.
okay, ma'am. Camera is on, ma'am.
It doesn't seem to be on.
Okay.
Okay.
Now let's see the history of generative AI. The generative AI did not appear suddenly. It is the result of many years of progress in data analysis, machine learning, and deep learning. This timeline shows how AI evolved step by step from basic reporting systems to advanced multimodal AI and collaborative AI systems. For stage one, basic reporting around the year 2000, organizations mainly used management information system. These systems were designed to collect data and generate reports. For example, a company could generate sales reports, employee reports, or financial summaries. However, these systems had a limitation. They could only describe what happened, but they could not predict the future or making intelligent decisions. So the AI at that stage was mainly focused on basic data reporting in first stage. For stage two, by around 2005, systems became smarter with predictive modeling. Instead of just reporting past data, computers started to analyze patterns and make predictions. For example, predicting future sales, customer behavior, forecasting demands. This stage introduced the idea that data can be used to estimate future outcomes. But the models were still relatively simple. For stage 3, machine learning, the next big shift happened around 2014 with the rise of machine learning techniques. The machine learning allowed systems to learn automatically from data without explicit programming. For example, it includes email spam detection, product recommendation on e-commerce sites, fraud detection in banking. Instead of humans writing rules, algorithms learned patterns from large data sets. This will be a major turning point for modern AI. For stage 4, around 2018, AI entered the deep learning era. Deep learning uses neural networks inspired by the human brain. This technology made it possible for computers to understand image, speech, text. For example, face recognition systems, voice assistants like Alexa, Siri, image classification. Deep learning greatly improved accuracy and performance in AI applications. For stage 5, the next revolution came for this stage. Unlike previous AI systems that only analyzed data, generative AI can create new content. For example, it includes writing articles or code, generating images, creating musics or videos, conversational AI like chatbots. Technologies like large language models made this possible by training on massive data sets. This is the technology behind tools like modern AI chat systems and create AI platforms. For stage 6, multimodal AI and collaborative. Multimodal AI means that it can understand multiple types of data simultaneously. For example, the text, image, the multiple data are text, images, audio, and video. This means AI can interact with the world more naturally. For collaborative AI systems, in the future, AI will replace humans but work together with humans. These collaborative AI systems will help in healthcare, education, and business decision making, and scientific research. Humans and AI will work as partners. These are the stage for history of generative AI from starting from 2000 to current 26 years. Next, the two sides of generative AI. The two sides of generative AI. The generative AI is a type of artificial intelligence that can create new content such as text, images, audio, video, or code. Many modern AI tools that we use today are based on this technology. In this slide, we can see two major sides of generative AI. The first side, we can see two major sides of generative AI. The first side, language AI, the language AI, which is based on large language models, commonly called LLMs. These models are trained on massive amount of text data and can understand and generate human-like language. So, common applications include chatbots and AI assistants such as chatbot that answer questions and help to the users. And content creation means where AI helps write articles, emails, reports. Then code generation, helping programmers to write software code and run the software faster manner. Then document summarization, where long documents are converted into short summaries. Language translation means converting text from one language to another. AI research agents, the research agents which help in searching and analyzing information automatically. So basically, language AI mainly works with text and language understanding. For the first side, the AI only mainly work on text and language understanding only. The second side, the image and multimodal AI, This type of AI works with visual and multiple data formats, such as image, video, and audio. Some important applications are face and object detection used in security systems. Autonomous driving vision, where AI helps vehicles understand the road conditions. Image generation means where AI can create new images from text descriptions. OCR means optical character recognition, which converts text from images into editable text. Video analytics used in surveillance and smart monitoring. Medical image AI, which helps doctors to analyze X-rays, CT scans, and MRI images. So this side of AI mainly focuses on visual understanding and multimedia data. The new trend today, the latest trend is multimodal generative AI. Instead of working with only text or only images, modern AI systems can combine multiple types of data such as text, image, audio, and video. This enables powerful applications like AI co-pilots and autonomous AI agents, which can assist humans in many tasks across different industries. Next, in this slide, we are going to understand what a large language model or LLM is. A large language model is a type of a system in generative artificial intelligence that is trained using very large amount of text data. This data can come from many sources such as books, websites, research papers, articles, and online documents. During training, the model learns different aspect of language. For example, it learns grammar rules, sentence structure, meaning of words, and the relationship between words in different contexts. Because it is trained on such a large amount of data, the model becomes capable of understanding human language and generating responses that sound natural and meaningful. This is why these models can answer the questions, summarize the documents, generate essays, and even write computer programs. One of the most popular example of LLMs in ChatGPT, LLM is ChatGPT, which was developed by OpenAI. Many students and professionals use this tool to ask questions, learn concepts, and generate ideas. Another example is Google Gemini, developed by Google, which also performs similar tasks such as answering questions and generating content. So large language model are AI systems that learn from huge amount of text data and can generate human-like language. These models are now widely used in education, business, programming, and many other fields. Now, how large language models are work? LLM are built using a deep learning architecture known as transformer architecture. This architecture was introduced in an important research paper called Attention in All You Need. This is a paper based on this paper content the transformer was introduced by using this research paper. The transformer model helps the AI understand the context in language. In human communication, the meaning of a word often depends on the words around it. The transformer architecture allows the model to analyze these relationships efficiently. Large language models typically work in three main stages. The first stage is pre-training. In this stage, the model is trained on very large data sets containing billions of words from books, articles, and websites. The second stage is fine-tuning. After general training, the model is adjusted to perform specific tasks such as answering questions, writing summaries, or generating the programming code. The third stage is text generation. When a user enters a prompt or question, the model predicts the next most probable word based on the patterns it learned during training. For example, if someone types the sentence like deep learning is a, this model analyzes the context and predicts the most likely continuation, such as subset of machine learning. This prediction process happens very quickly using probability calculations across millions or billions of parameters. This is how LLMs generate natural language responses. Now let's see the three phases briefly. The first phase, pre-training phase. In this slide, we will look more closely at the pre-training phase, which is one of the most important stages in building a large language model. During a pre-training, the AI model is exposed to massive data sets. These data sets include a wide variety of text sources, such as books, website, online articles, academic research papers, etc. The purpose of this stage is allow the model to learn patterns in human language. The main objective during pre-training is predicting the next word in a sentence. Let us look at this example shown on the slide. The input sentence is deep learning is. This is the input sentence. The model then generate several possible predictions for next word. For example, A, powerful, important, and used. These are the next word possibility. Then each word has some probability score. The models based on customers review, the probability score will be displayed here. Each word has a probability score. The model selects the word with the highest probability after selecting the next word. The process of continues again to predict the following words. So the sentence may gradually become. Deep learning is a subset of machine learning. This method of predicting the next word repeatedly is known as language modeling. Through this process, the model learns how sentences are structured and how ideas are expressed in human language. Over time, after analyzing billions of sentences, the model becomes capable of generating meaningful text and answering questions accurately. That is why the pre-training phase is considered the foundation of large language models. The next, we have to see the fine-tuning. After a model is trained on general data, it often needs to be adapted for specific tasks. This process is called fine-tuning. There are two major approaches here. First one is supervised fine-tuning. Here, the model is trained with labeled examples. For instance, if we want a model to classify emails as a spam or not spam, we provide many examples with the correct labels. The model learns patterns directly from this structured data. Second one, the reinforcement learning from human feedback, RLHF. Instead of just labels, human ranks responses. Imagine asking the model, what is the capital of France? It may generate several answers. Humans then rate them based on best, good, or poor. The model uses this feedback to improve learning, not only correctness, but also clarity, tone, and usefulness of that particular words. This approach has been key in making AI systems more aligned with human values and expectations. Together, these methods enhance safety, accuracy, and trustworthiness in AI systems. In next, the text generation happens during what we call the inference phase. Imagine you type the prompt, deep learning is powerful. First step, convert text into tokens. The words are broken into small units called tokens. For example, here the sentence is deep learning is a powerful. The tokens are deep. Then learning is unpowerful are the tokens. Each token is mapped to a number the model understands. Pass the tokens through transformer layers. These tokens flow through multiple transformer layers. Each layer refines the representation, capturing context and meaning. The model then predicts possible next words. Then third step, calculate probability distribution. The model does not just guess one word. It assign probabilities. For instance, A 42% chance, for powerful 30% chance, important 18% chance, and widely is a 10% chance. Select the next token. Based on these probabilities, the model picks the most likely word. In this case, it chooses a. It chooses a because the highest probability is for A. 42% is highest probability. So next word is taken for A. Continuing this process, the model might complete the thought as deep learning is a subset of machine learning. The every token, the probability will be continued till last enter into the last word. This cycles repeats until the model produces full coherent responses. Text generation is not random. It is a structured process of tokenization, contextual analysis, probability calculation, and word selection. This is how AI transforms a simple prompt into a meaningful sentences. So in this slide, how LLMs like ChatGPT work step-by-step process. First step is data collection. First, the model learns from massive amount of data. Already we know that the textbooks, academic papers, web pages, articles, even code repositories. The goal is not memorization, but learning patterns of how language is used. For example, by reading thousands of sentences about astronomy, the model learns that words like gravity and black hole often appear together. For step 2, tokenization. Next text is broken into smaller units called tokens. Take the sentence, A is transforming technology. It becomes A is transforming technology. The word tokens are separated. Each token is mapped to a number of numbers, so the computer can process it. Think of tokens as puzzle pieces. The model builds meaning by arranging them. Step 3, transformer architecture. Now comes the heart of the system. The transformers use attention mechanisms to understand relationship between words. For example, the animal did not cross the street because it was too tired. So in this here the model learns that it refers to animal. In this sentence, it will be refers to as animal. This ability to track context is what makes transformers so powerful compared to older models. For step 4, training model. During training model, the model predicts the next word in a sentence. Checks if it is correct and adjust itself. For example, the sun rises in the model predicts east. If it is wrong, the system corrects itself. This because ChatGPT that can be trained. So the sun always rises in the east. So it is correct. So the ChatGPT complete the sentence by east. Suppose we give wrong west means it automatically tell them the sun rises in the east. This process is repeated billions of times using powerful GPUs until the model becomes highly accurate. For step 5, finally, when you type a prompt, the model generates a response. It goes through 4 steps. Convert your input into tokens. Then second step, analyze context with the transformer layers. Then third step, calculate probabilities for possible next words. Then fourth step, select the most likely sequence. For example, if you ask what is black hole, the model might respond, a black hole is a region in space where gravity is so strong that nothing can escape it, not even light. Uh, Data collection teaches patterns, tokenization. Tokenization breaks text into pieces. Then transformers understand context. Training refines predictions, and inference generate responses. Together, these steps explain how ChatGPT transforms your questions into meaningful answers. I hope these 5 steps are these 5 steps are used to convert your text into your GPT, transform your questions into meaningful answers. Next, there are 3 key technology behind large language model. That is machine learning, as we know that machine learning, deep learning, and natural language processing. These are the building blocks that make system like ChatGPT possible. Machine learning. First, machine learning. Instead of explicitly program, computers learn patterns from data. For example, if you feed a system thousands of emails labeled spam or not spam, it learns the patterns that distinguish them. This ability to learn from examples is the foundation of all modern AI. The next deep learning, this uses artificial neural networks with many layers to process complex information. Think of it as a think of it how neurons in the human brain work. For example, in image recognition, one layer might detect edges, another shapes, and a deeper layer recognize entire objects like a cat or car. In language models, these layers capture grammar, meaning, and even subtle context. Next, natural language processing. Finally, the natural language processing or NLP, this field focus on enabling computers to understand and generate human language. For example, NLP allows a model to answer what is the capital of France with Paris. It helps the model grasp nuance. Nuance means understand the subtle meaning and hidden details in language or situations. NLP is what makes interaction with AI feel natural and human-like. These are the key technologies behind LLMs. Now, the applications of NLP include language translation, sentiment analysis, chatbots, text summarization, and speech recognition. These are applications of natural language processing. Now, let's see about the applications of generative AI in LLMs. These chatbots and virtual assistants, content writing, code generation, language translation, text summarization, and education supports. These are the applications of generative AI. Now let's see about generative AI in large language models with real examples. First one, let's start with education. One of the most impactful areas where generative AI is already making a difference. Students use AI tools to explain difficult concepts and generate algorithms, summarize long chapters, prepare seminar content. For example, a student explain Navy bias algorithm with example. The student asks ChatGPT to this question means this is prompt. The AI instantly provide the clear explanation about this algorithm. This saves time and help students grasp complex topic faster. It's like having a tutor available 24/7, but it's not important to use AI as a support tool, not a replacement for critical thinking. Because AI only a supporting tool, not a replacement of critical thinking. The critical thinking is by human, is for efficient one. How many of you have used AI tools to clarify a concept before exams? So respond in chatbot. How many of you used AI tools to clarify concept before the exams? So I will ask the questions in fast. Next, content writing. Next, let's look at how AI supports bloggers and marketers to write content. AI can write blog post, create social media captions, generate product descriptions. For example, a company launches a new 5G smartphone. The prompt like write a promotional caption for a new 5G smartphone. Then the AI generate an attractive caption instantly. This reduces workload for marketing teams. AI ensures consistency in tone and style. It helps a small business complete by producing professional content quickly. Next, code generation. Developers are also benefiting from generative AI. AI can writing programming code, debug the errors, convert code between languages, assist in software development, for example, Dept and Copilot. For example, the prompt was write a Python program for linear regression. AI generate the code instantly. This boosts productivity and reduces repetitive tasks. Developers can focus on design and logic while AI handles uh, bilateral code. I think it's like having a coding assistant who never gets tired. So the developer focus on only design and logic while AI handles bilateral code only. Code not only bilateral. If you give bilateral code, the AI generate the full code. Uh, then uh, then we have to see healthcare. For healthcare is another field where AI is transforming workflows. Doctors use AI to summarize patient record, assist in medical documentation, provide research summaries. For example, a doctor uploads patient's notes and AI generates a structured medical summary. This saves time and reduce the paperwork. Doctors can spend more time with patients instead of documentation. AI also helps in keeping track of medical research updates also. Then next one is language translation. The LLM language translation is one of the most visible uses of AI. AI translate languages instantly. For example, good morning. This sentence into French means it converted bonjour. This helps in global communication. Uh, Businesses can reach international customers more easily. Students can access resources in different languages. It breaks down barriers and promotes inclusivity. Uh, then, then next, we have to use in business side. For companies use AI chatbots for customer support, marketing, content creation. For example, a marketing manager asks write an Instagram caption for a new sports shoe launch. The AI responds run faster than ever. Introducing our new lightweight running shoes designed for speed and content. These are generated by AI. AI reduce response time in customer service. It creates engaging marketing content at scale. Businesses save cost while improving customer experience. These are the applications used in generative AI. Applications in generative AI. Now let's see about what are the limitations and challenges behind them. While AI brings incredible opportunities, it's equally important to understand its limitations and challenges. Let's look at four key concerns. First one is hallucinations. Next, bias, privacy, and ethical issues. Now, see one by one. Hallucinations. Sometimes AI generates information that sounds correct, but it actually wrong. This is called hallucinations. For example, it might invent a reference or misstate a fact. That's why human verification is essential. AI should be seen as a helpful assistant only, not a flawless source. Next, bias. AI learns from data, and if the data contains bias, the outputs can reflect it. For instance, biased training material influence hiring recommendations or language use. Researchers are working to reduce this, but awareness is key. Users must critically evaluate AI outputs. The next one, privacy concerns. AI systems often process sensitive information. Protecting privacy means ensuring data is handled responsibly with safeguards against misuse. Transparency and secure practices are vital in building trust. The next, ethical issues. Finally, ethics. Responsible AI use ensures fairness, safety, and accountability. Developers and organizations must ask in this application serving people positively. Ethical frameworks guide how AI should be deployed in society. AI is powerful, but responsible use and human oversight and our oversight are what make it truly valuable. These are the limitations and challenges behind the generative AI. Next, the future of generative AI. First, accuracy. Current models sometimes make mistakes, but future systems will be better at fact checking and reducing errors. Imagine asking a complex question and getting response that's not only fluent but also highly reliable. The next one, second, multimodal AI. This means system that can understand and generate across text, image, and even videos. For example, you could upload a picture and ask for a written explanation, or combine video with text prompts. This open up entirely new ways of interacting with technology. Next, personalized AI assistants. The future AI assistants will adapt to your preferences, learning your style of communication, your interest, and even your personal needs. Instead of generic answers, you will get responses tailored specifically to you. Then last one,
Miss Maria, are you still with us? Okay, it seems like your connection is lost again. I'm sorry for the inconvenience, but please wait a minute. Hello, Miss Maria.
Yes, ma'am.
You're with
Network
us?
is that's
Okay.
weak. Okay.
Okay, it's okay.
Okay.
You may continue, please.
Yes, ma'am. Yes, ma'am. So comparison of different LLMs. GPT-3 released in 2020 was the first widely recognized model for text generation, summarization, and information retrieval. GPT 3.5, better known as ChatGPT, built on is this by improving conversational responses. It becomes popular because it could hold natural flowing conversations, making AI more accessible to everyday users. GPT-4 took things further with enhanced logic, longer answers, and better chat capabilities. It can handle more complex reasoning and provides detailed analysis thanks to expanded token window. This means it can process and generate much longer pieces of text into text on go. Next, GLAD developed by Anthropic emphasize accuracy and high-level reasoning. It also support image inputs, making it more versatile. Its design focuses on safety, reliability, which is crucial for professional use. Next, Gemini. Gemini comes in text and multimodal version. The text model excels at detailed analysis and logical reasoning, while the multimodal versions can handle multiple data types, text, image, audio, and video. This multimodal capability is major step toward AI systems that understand the world more like humans do. Uh, Next, when choosing an AI tool, one practical question is how much can I use it for free? The slide compass popular large language models like ChatGPT, Claude, Gemini, Copilot, Perplexity, and Hugging Face models based on free access and usage limits. For GPT-4, OpenAI's GPT-4 offers access, but free users have limits. Only a certain number of messages every few hours. GPT 3.5, however, it's usually unlimited. This balance allows people to try advanced features while encouraging upgrades for heavy use. For GLAD, by Anthropic also provides free access, but limits range from about 20 to 50 messages depending on the size. It's designed to give high quality reasoning while keeping usage manageable. Then Gemini is available free in browsers and APIs, often allowing 60 plus prompts per minute or daily chart limits. It's generous for experimentation, especially for developers. We have to use Google Gemini. Next, Microsoft Copilot integrates GPT models and offers mostly unlimited daily charts. This make it convenient for productivity tasks like writing, summarizing, or coding directly inside Microsoft apps. Then Perplexity. Perplexity AI provides free searches and limited GPT-4 queries per day. It's useful for quick fact checking and research with a balance between advanced and basic features. The last Hugging Face host many open source model. Asir is free, but limits depend on the specific model and server load. This is a great opinion for researchers and developers who want flexibility. Each platform offers free access, but with different limits. ChatGPT and Glad restricts messages. Gemini and Copilot are more generous. Perplexity balances advanced queries with basic searches, and Hugging Face provides open source flexibility. Knowing these differences help you choose the right tool for your needs. Now I conclude this session. As we to the conclusion of our session, let's quickly recap takeaways about generative AI and the large language model. Generative AI is powerful because it can create new content, whether the text, image, or even code. This ability makes it useful across education, business, healthcare, and many other fields. It's not just analyzing data; it's producing something and new and meaningful. Large language model are trained on massive data sets. Books, articles, websites, and more. This training allows to understand patterns in language, so they can respond in ways that feel natural and human like. They don't memorize, they learn how words and ideas to connect. Next, transformer. The real breakthrough is transformer architecture. It helps model understand context, like knowing that in the sentence, the animal did not cross the street because it was tired. The word it refers to animal. This contextual awareness is what make AI response coherent and relevant. Next, finally, tools like ChatGPT shows us the practical side of this technology. From explaining concepts to generating content, they demonstrate how AI is already integrated into everyday life. Generative AI creates LLMs understand transformers, provide context, and tools like ChatGPT bring it all together. The journey of AI is about combining these technologies to make our lives easier, smarter, or more connected. Thank you for being part of this session. Now, any queries, please post it on your chat box.
All right, thank you, Miss Maria, for the presentation. We will now begin our Q&A session. So if you have any questions, please don't hesitate to type them in the chat or use the raise hand feature to ask directly. But it seems like we already have some questions here in the chat. Let me read it to you. So the first question is from Hansu. What are some real-world applications of LLMs beyond chatbots like ChatGPT?
For example, YouTube. YouTube, we have to search some content. Next, we have to see that videos, the recommended videos only. So into YouTube, if I watch songs, means the songs will be recommended to me. This is also worked related to ChatGPT. So generative, that recommend that system.
All right, I hope that answered your question, Hansu. And for the second question, as we wrap up this session, is from Yuvena. If LLMs fundamentally operate through probabilistic token prediction, what mechanisms enable them to produce responses that appear to involve reasoning or structured thinking?
Based on customer reviews, I think that likes, for example, we have give some questions to ask to ChatGPT means that produce some related content. After producing that content, some like or dislike content will be appeared here. The user may give like or unlike means based on these probabilities. They took a answer to next level. I think so.
All right. Thank you, Miss Maria, for the answer. I hope that answers your question, Miss Ivana. So, as we wrap up this enriching lecture, allow me to invite everyone on this lecture to a group photo for documentation. So please don't hesitate to turn on your cameras and smile.
Okay.
And I will count to 3 as the admin will take our picture. Okay, 1, 2, 3. Okay, once more for a good measure. All right, thanks to all of your active participation. As we conclude this lecture, I thank each participant for their dynamic involvement, unwavering engagement, and palpable enthusiasm throughout this enlightening affair. My profound appreciation is directed to our distinguished guest speaker, Mr. Mr. Asir, and Ms. Maria. We stand genuinely privileged to have had you grace us with your expertise. Thanks are also owed to the participants whose incisive queries and contributions during the Q&A session have indisputably contributed to this lecture. Moreover, such success would not have been possible without the unwavering efforts of our event organizers, sponsors, and technical support teams who worked discreetly behind the scenes. Please remain connected with us for forthcoming events and opportunities. Your presence is invaluable, and we eagerly anticipate your participation in our future undertakings. Once again, profound thanks for your participation in this lecture. I wish you all an exceptional day ahead. Take good care. Farewell. Have a good rest of the day. We hope you will. Bye bye.